Okay, good afternoon. Wanted to do this video early this morning and just got sidetracked with some things. Um, I promised a shortcut in Google Sheets for doing a confidence interval, and after really reviewing it, it's not really that much of a shortcut. But here's a quick review. We have an equation for finding error. That equation is error is equal to ZC, the Z-score for a given confidence level, times standard deviation divided by the square root of n, which is our sample size. So, really quick, it's one of the assigned problems today. It's number 21 in the 6.1 exercises. They want us to create a 90% confidence interval, which tells us our ZC is going to be 1.645. That's one of the three that I told you were good to have memorized. They tell us we have a sample mean of 12.3, a sample standard deviation of 1.5, and a sample size of 50. This is sample standard deviation, not population standard deviation. However, since our sample size is greater than or equal to 30, we can use sample standard deviation. So our error equation is to do our ZC times our standard deviation divided by the square root of our sample size. So I've done that, okay? 0.35 is rounded to 2 decimal places. Quick little tip here. I know I've been telling you to go to format and format the number to whatever decimal place you wanted. There's also buttons up here. I just learned this. But you can increase or decrease your number of decimal places. So if you wanted to increase from 2 to 3, you can do that. If you want to go back to 2, you can do that. 2 is sufficient in this case. So that calculates our error, and that's using our error equation. And if we want to create then the confidence interval for this problem, we want to do our mean value minus our standard deviation to give us our low end, and our mean value plus our standard deviation to give us the upper end. So this is our 90% confidence interval. It goes from 11.95 to 12.65. So there is a shortcut, sort of, in Google Sheets. Sometimes it's a shortcut, sometimes it isn't. And it's this command confidence.norm. Okay, this will help us find the error. It will not jump all the way to the confidence interval. You're still going to have to do the addition and subtraction. So the command is confidence.norm, parenthesis. The inputs are alpha, and we'll talk about that in a second, comma, standard deviation, comma, n. Alpha is defined as 1 minus your confidence level. So in this problem where they told us 90% confidence level, our input there is going to be 1 minus 0.9. Now you can just type in 0.1. I chose to type in 1 minus 0.9 so that I get it correct every single time. Our standard deviation again was 1.5, and our sample size was 50. If I input that with an equal sign in front of it, it will do this calculation. You can see here it is up here. Equals confidence norm, 1 minus 0.9, 1.5, 50. And it gave us the same 0.35 we got from our error equation. Okay, so it'll calculate the error. We still have to jump down here. We still have to do 12.3, our mean, minus our error, and plus our error. And we still will get the same 11.95 to 12.65. So we'll get the same confidence interval. So is this a shortcut? Well, for ZCs that we know, 90% is 1.645, 95% is 1.96, and 99% 2.575. It's not really much of a shortcut. The error equation is pretty simple to input and then do your addition and subtraction. What is it really good for? Those questions where they ask for some goofy ZC value or some goofy confidence level. So if they asked you to do a confidence interval for 87%, then it certainly would be a shortcut, because then you could do equals confidence norm, and you could input 1 minus 0.87, and same thing in this case, we'll use the same values, 1.5 and 50. So if they asked you to do something like that, an 87% confidence interval, which is not something we normally would do. Did I spell something wrong here? Equals is unknown. Dance.norm. It's giving me an error there because it doesn't like something I typed in. Try it again. Equals. There it is. I probably spelled something wrong or did something. Again, 1 minus 0.87, and this is just what I'm making up, comma 1.5, comma 50. It would give us our error. We could drop that down to 2 decimal places. It automatically rounds it, which is nice when you do this. And then we could just, calculate our equals 12.3 minus that number, and equals 12.3 plus that number. And there you go, 87% confidence interval. So that's what it's really good for. Just go up here, say C equals 87%. Standard deviation. Still the 1.5. And this is, again, something I just made up just for an example. And equals 50. And equals 12.3. So it's a shortcut for things where you don't know the ZC value off the top of your head. That's about it. Everything else there today is pretty straightforward. If you have any questions, you can shoot me an email, but I think you'll be all right. So thanks for listening.